talking about AI and machine vision and what type of role they're going to be playing in advanced manufacturing in the coming years. So Research Centre. We were established in 2001 as a collaboration between Boeing and the University of Sheffield, and that sort of link between industry and academia is something that we keep to this very day, and I'll go over a little bit what that really means to us and how that impacts the work that we do. But our mission statement is to help manufacturers of any kind and any size within the UK to become more competitive and more profitable by introducing advanced techniques, technologies and processes. So we de-risk it, make sure that it works, and then putting it off into industry. We have over 700 researchers, technicians and support staff here, so we have a large capacity for doing a large range of projects, and we have over 120 member companies, from global giants to local SMEs. We brought over £200 million of investment to former coalfield here in Sheffield, to the Orgreave colliery, and we continue to work with Rolls-Royce and Boeing as part of their global research networks. So these are some of the AMRC members here that you'll see. For instance, we've got world-leading companies such as Rolls-Royce, BAE and Accenture, who Graham works for. And we've got local suppliers as well here, such as Footprint Tools, local SMEs in Sheffield and the surrounding regions who do little bits of work. We work with all shapes and sizes in order to make UK manufacturing more competitive. So this is sort of the region that we sit in as well. I don't know if you're familiar with the MRL scale, but it's a scale of how mature a technology is, where number one is it's sort of a scientific concept. It's been done in a lab somewhere in a university. And number 9 is it's been in use for ages. We know all the metrics about it. We know what this technology is. And we sit in this gap between 3 and 7. So getting it from production, proof of concept, experimental proof of concept, to the point where it's in pre-production, at which point we hand it over either to an integrator or the actual end user themselves to then run with that technology and then work with it. This is the sort of sample process that we undertake, where we take low-level technology from academia, we develop proof of concepts, we make it more mature, and then we hand it over to into industry integrators and production. Right, so this is the main body of the speech now, after we get the introductory spiel out of the way. The growing need for machine vision in advanced manufacturing. So we work with all these different companies from all these different industries, but what we see is they seem to have the same needs, same requirements for machine vision and for AI in their industry. And the main sectors where we're seeing the largest drives at the moment are aerospace, pharmaceutical, rail and construction. This is where we're seeing the largest increase in interest in this sort of area, machine vision for AI. Additionally, we're seeing new sectors starting to emerge and become increasingly more interested in this type of area of work. So new sectors include additive manufacturing, autonomous vehicles, and composite materials. And finally, the main area where we're seeing growing need for machine vision is in supply chains, and the need to reduce the amount of the length of supply chains and increase the overall resilience of supply chains in general. So what do these high-value manufacturers want? What do aerospace, pharmaceutical, rail, construction, all these advanced manufacturing firms, what do they want from a machine vision system and an AI system? They want flexibility. High-value manufacturers, they make small batches of a wide range of components, a wide range of very valuable components. So they can't have a machine vision system and an AI system tailored for each specific type of component. They need something that's flexible, something that can do a range of activities. Otherwise, they don't have enough space to actually put these technologies into their facilities. They want systems to be scalable. They want them to be able to scale with their components and with their production. So they want it to be able to say, I want this that can inspect a turbine blade that's this big, and scale it up so it can also inspect a fan blade, which is 50 times the size of it. They want this technology to be adaptable and scalable. They want traceability in it. They want to be able to link the decisions that are being made by AI and machine vision systems and be able to actually trace them through the life of the component, so they can say, I know when this decision was made about this component at this time, this is what it's done, and this is what it looks like over its life. Validation. They want to be able to say, this system will work. This system will work because we've proved it out. We tested it to its limits. We know that this will work. An aeroplane won't fall out of the sky because we are absolutely certain that this system will work. Now, moving tact a little bit, we're seeing an increased drive amongst advanced manufacturers to reduce supply chain. And this is very, very poignant at the moment in particular, in that most governments want to end manufacturing supply chains in pharmaceuticals, antibiotics, and medical equipment and revert to national production. This instinct is likely to spread to high-tech sectors, and it means taking away production from China. So that's Helen Thompson, Professor of Political Economy at Cambridge University. And this is very, very much what we're seeing as well from industry. They want to take supply chains and reduce them. So of the Fortune 1000 companies, 90% had suppliers in their supply chain in Wuhan, China. So when the coronavirus crisis started to hit all the way back in 2019, the supply chains were immediately exposed and left vulnerable. So the impact of coronavirus to UK manufacturing started before coronavirus really started to impact UK society. Now, because of this, there's this drive to make these supply chains more resilient, make them so that they're not going to suffer such global shocks, so they're not going to take that and really have impacts, because a supply chain, like any chain, is only as strong as its weakest link. So how do we make this better? And that leads us to this. So why do we have supply chains in the first place? Why are they spread out so much? Now, they're spread out to reduce costs. So how do you reduce the supply chain length? You have to reduce the cost of internal manufacturing. You need to reduce the cost of manufacturing components within the United Kingdom. How do you reduce the cost of internal manufacturing? Well, you need to increase the amount of automation that you have in the process. How do you do that? Machine vision. So machine vision and artificial intelligence within the machine vision is how you're going to reduce supply chains by increasing automation and making British manufacturing more competitive, more cost effective, more cheap. Now, how do we operate? We at the AMRC, we currently conduct areas of research in many areas of machine vision and artificial intelligence. So we look at automated inspection, product tracing, robotic guidance, process monitoring, AI for a wide range of activities, and 3D inspection. These are the main areas where we're currently researching machine vision. So what I want to do now is give you 3 different example applications and different areas of research that we've worked in a few different sectors. So the first example I'm going to walk you through is talking about a partner-specific application which we've worked on to solve with a large aerospace firm here. Now, a large aerospace partner of the AMRC approached us with an application saying they want to automate the visual inspection of complex sheet metal components. And this application very much highlights what I was showing about what advanced manufacturers actually want from this. So there was a wide range of features on these components, and there was a wide range of components in general that they needed to inspect. And as we see here, it's that need for flexibility, being able to take these sample components with different features and inspect them using the same system. It's that need for scalability. They want it to be able to be implemented in a wide range of environments. They want it to be able to deal with a lot of different components of differing size and shape. And they want it traceable as well. So they want to be able to say, this system made this decision on this component. I can trace that right back here, like they do with operators at the moment. And they want to validate the process. They want to say, okay, we've got this new AI system. How can we show that it is as good or better than the current human inspection process, which is really key, and it's surprisingly difficult. It's possibly the hardest part of this entire process. So based on the requirements and the samples that they gave us, the AMRC embarked on a series of development activities to create this proof of concept inspection system. So we did it quite rough, quite rugged, considering how advanced the actual components are and how advanced we're supposed to be. We've got the metal frame, set it up, set up the camera so we could start acquiring data, start making a sample. Now, I think at this point, it's important to identify what is the difference between artificial intelligence and machine vision for these types of activities. Now, there's a couple of approaches you can take in machine vision. The classical approach, where you say the camera will take this picture, we'll give it data, and we'll give it rules. Now, you pass that through a classical machine vision system, and you get results. You get, there's this many holes, there's this many edges, there's this difference, there's this intensity of light. However, when you're training an AI system to do these types of activities, you're not giving it data and rules. You're giving it data and results. You're saying in this image, there is a crack. In this image, there is burning, there is melting. And the AI machine vision system then learns the rules and outputs them instead. So you're then using that instead of actually manually going in and processing it. And we found that you can use both of these methods in tandem to produce a much more competent system than was previously possible and is possibly available just by using them individually. So we used it, we attacked a lot of different applications here. So using AI to identify spot welds in the actual surface, using AI to identify countersinks and their location, and using classical machine vision to decode data codes and to perform dimensional analysis. In this sense, we got AI and classical image processing techniques to interact with each other and to complement each other's strengths and weaknesses. This is an example of using the system to identify rivets on a component in real time and to count them and give their location. So we load the system in, we load the component in, say this is the component that we're looking at. We want to be able to identify these rivets all around the surface of this component. Starts on the first one and then finds every single rivet in the actual image itself. Counts them up, 113 rivets identified. Much faster, much more accurate than a human. You can see actually processing in real time and identifying them as quickly as it can. So this is a very fast system for identifying these rivets, and it's scalable, it's flexible, because it knows what rivets are. It doesn't know what this component is, it knows what rivets are, it knows how to find them. In the same way, if you told a human, go over there, find all the rivets, count all the rivets in that thing, it doesn't matter what that thing is, it knows what it's looking for. And that's how this system operates. So we're still working on this. It's still live, and we're looking at actually putting this into production now, and we're looking to work with partners and systems integrators to support this solution into production. So if anybody wants to get in touch after us, talk about this type of project, this type of activity, please feel free to do so. Example 2, we're doing pure AI inspection. This is in a different field to aerospace. This is in medical. So this is looking at automated inspection of artificial knee joints. So loading knee joint into a system, we're imaging it using a robotic imaging system to light it uniformly and get images of all the different contours and actual perspectives of the knee joint. And then we can load it into our AI dashboard. So this is using IBM's Workplace, who we do a lot of work with. Done a lot of work with IBM to get AI solutions actually on shop floors. So this is one, bringing in the knee image, quickly processes it, identifies a scratch, identifies 2 holes, and classifies them. Now, this is a model which we have used, we've trained it, that's it working in real time. We've trained it based on examples of defects. So not in examples of knee joints. It doesn't know what knee joints are, really. It knows what scratches are. It knows what holes are. And that's what it's looking for. It doesn't matter on the shape or the size of the knee joint. It matters on, does it have scratches? Does it have holes or not? So this is something that we're currently trying to do to automate these sensitive inspections in the medical industry. And this is what's needed for this type of inspection. To perform this activity using classical machine vision is far too difficult, and it's almost impossible. We know that, we've tried it. So it's too hard to actually do it and make it adaptable. You need artificial intelligence to do that. We're also doing low-level research into new technologies. So this is an example of a new type of imaging called polarization imaging, where we're not capturing the intensity of light so much as we're capturing the actual orientation of light. So we take this metal surface, for instance, which has weld defects on it, these little weld blobs. we image it, and by taking the actual direction of light, you can see how clearly defects start to stand out, because the surface light coming off the actual flat background, not very rotated, but when it's coming off these blobs, really is quite rotated, and we can now pick that out and discern that. So when we then take this, we then apply it through our AI system looking for these defects, it can highlight them very, very easily. Give that back to the original image, highlight that to an operator. So this is a very fast industrial inspection. So yeah, we're working on this type of technology. We're working on all sorts of different low-level technologies, and we're always looking for further applications of low-level technologies. And we're also always looking for new low-level technologies themselves to take forward and work into production. So if anybody is there with low-level technology, low-level new processes that they want to prove out, they want to demonstrate, this is an area where the AMRC is always looking to work, and we're always willing to work with partners to demonstrate new technologies. And yeah, we're always looking to nurture new working opportunities with UK-based manufacturers. And if that is by demonstrating your technologies to all these different manufacturers that we work with, to Rolls-Royce, to BAE, to Boeing and Airbus, then that's something that we want to do. We want to collaborate with. Now, that's what we do. We bring advanced manufacturing techniques to all industries. We're here to aid UK manufacturing. To this end, we're always looking for people to work with. So if you do have any sort of applications in this field, please do get in touch. We are not for profit. We don't actually sell anything ourselves because we're a faculty of the University of Sheffield. We're here to actually facilitate engineering. We are not here to profit from it. We're here just to help nourish UK-based manufacturing. Now, working with the AMRC can take a variety of forms. That's collaboration on projects in order to deliver production-ready solutions, partnerships to demonstrate technologies and solutions to some of the largest names in manufacturing, and networking to allow productive working relationships to grow by connecting people from different industries, suppliers of different technologies to new industries. We're always open to working with new businesses, and we're always looking for new technologies to provide a benefit to the UK manufacturing. So that's the end of it. We're always working in new areas, new technologies, and we're doing a lot of work in machine vision and AI. If anybody has any more questions, these are my contact details here. And if you want to if you want to get in touch about any specific applications you may have, or if you want any further information about the applications that I've talked about during this talk, please feel free to get in touch. I'd be more than happy to discuss that with you.